everyone, so today I'm going to be telling you about the discovery of the nucleus, okay? So, first of all, let's just get a background information about everything that we know so far about alpha, beta, and gamma, and about atoms, because this is going to make us understand how the nucleus was discovered, okay? So, you can answer these questions, which I'll show the answer in a second. So, draw the label and the structure of an atom, make sure you include the protons, neutrons, electrons, and their charges, and then match each of the particles to a definition where I have what alpha, beta, and gamma particles are. Okay, so an alpha particle consists of 2 protons and 2 neutrons. Okay, they are positively charged and they are the same as a helium nucleus, so A would go for 3. A beta particle consists of a fast-moving electron. They are negatively charged and they are the same as an electron, so B would go for 1. And then gamma particles have no charge or mass, they are waves. So C, gamma, would be 2 electromagnetic waves. So for this particular lesson or video, you need to know very well about the alpha particles, okay? And in terms of an atom, well, an atom has a nucleus and electrons moving around in a nucleus. So that's the nucleus at the center, the electrons going around. The electrons carry a negative charge, and the protons and the neutrons, which are inside of the nucleus, carry different charges. The protons have a positive charge and the neutrons have no charge, neutral. So this means that the atom overall, because it will have the same number of protons and electrons, will have a neutral charge or a charge of 0, okay? An atom that has a charge is going to be called an ion. It's because either it lost or gained an electron. They can never lose or gain protons, okay? In that way, or well, something else would happen, but I'm not going there now. So when it's about making ions, it's about electrons, okay? So, how was the nucleus of the atom discovered? There were some scientists, Ernest Rutherford, and he was with his research workers, Hans Geiger from the Geiger counter, and the Ernest Marsden, I hope I'm saying it right, Marsden, and they decided to investigate the scattering of alpha particles by a thin metal foil. Now, remember, alpha particles are positive, okay? So this is how they set up the experiment. This is the source of the alpha particles, and it was in a lead box containing the alpha radiation source, so nothing would come out apart from in this part where there is the opening. They had the gold foil, they had a radiation detector that they could move around, okay, and they had an evacuated chamber, okay. So they were sent alpha particles, let them go through the gold foil, and then they would move around the detector, Geiger counter, to check if they're finding anything on the other sides. And you can try this. So I'll give you the results in a second, but you can try this exact experiment with marbles. So what you can do is get someone that has the finger on the table, for example, so the finger pointing down on a table, and try from a good distance, because remember the atom is quite large in relation to where the nucleus is. Remember that video, if the atom would be a stadium, the nucleus would be a beam in the center of the stadium. So try to roll the marble and see if you hit the finger. The finger would be the nucleus and the marble would be the alpha particles. Count the number of tries, see what is the overall result, okay? And then you will see that actually your results, at least when I do this with my students, your results tend to be the same as the results in the experiment, which were the following. Most of the alpha particles pass straight to the metal foil, meaning most of the times you throw the marble is not going to hit the finger, okay? This, again, you need to do it at a distance, and you need to leave the marble to roll towards the finger, the nucleus. The number of alpha particles deflected per minute decreased as the angle of deflection increased. So when you would get the alpha particles or the marbles to go near the nucleus or the finger, you would see that they could change direction, okay? But they wouldn't change direction as much, okay? And then about 1 in 10,000 alpha particles were deflected by more than 90 degrees, meaning they would kind of hit something very well, I didn't want to say now, but very massive, very dense, and bounce back, okay, deflect back. And again, this is the same you would see if you would do that experiment with the finger and the marbles, okay? Now, what do these three results tell us about the nucleus? Well, the conclusions were: Rutherford could deduce that there is a nucleus at the center of any atom, which is, and I have the three properties of the nucleus. Try to do it yourself, freeze the video or pause the video, otherwise let's see the answers. He said that the nucleus had to be positively charged because it was repelling alpha particles, which they already knew were positive, okay? Now, like charges repel, and it's said that some particles, alpha particles, the ones that were not going through, they were being deflected, meaning changing direction away from the nucleus. He also concluded that the nucleus was much smaller than the atom because most of the alpha particles passed straight through without being deflected. So they were passing through as if they were passing through mostly empty space, okay? So the atom is mostly empty space. And finally, he deduced that most of the mass of the atom is located in the nucleus because some alpha particles were bouncing back, were being deflected by more than 90 degrees. Okay, so it all makes sense. I mean, if alpha particles are positive and they are passing through, it means that there's nothing in there, so nucleus is tiny. If they are sometimes being deflected, it means that sometimes they meet something that has the same charge as them, so the nucleus must be positive. And then if sometimes they were bouncing back, it means that they were going in such a route or direction in which they would actually not even get deflected, bounce back completely. And this would say that the nucleus was quite massive, quite dense, you know. So nucleus has a very small volume, but a lot of mass inside. Now, his model, Rutherford's model, was quickly accepted because it was in agreement with measurements by other scientists, Geiger and Marsden, and I hope I'm saying it right. It also explained radioactivity, that happens to be what happens to an unstable nucleus when it emits radiation. And finally, it predicted the existence of the neutron that later on was discovered. And this is kind of how science works, okay? You get some results and you see if it matches with other things that we already know, or if it can be explained by stuff that we already know as well, okay? So, people said bye-bye to the plum pudding model, this one, which I'll get in a second, and said hello to the nuclear model. So, we stopped thinking that the atom would look like this, plum pudding, and would look like this one, the nuclear model. So in the plum pudding, we said that an atom was solid, overall positive, with bits and pieces of electrons that would be negative, and this would give you the neutral charge. Now with the nuclear model, we say that the atom is mostly empty space. It has electrons orbiting a positive nucleus, which is very small and very dense, okay? So, just to finalize, let's do this exercise. Try yourself, get some properties of the plum pudding, get some properties of the nuclear, and then let's see if it's right. So, atom is solid, that's the plum pudding. Oh, this particular slide is not mine, okay? Nuclear model, let's say, oh, positive charge concentrated in the center, okay, nuclear model. Positive charge throughout the atom, that would be the plum pudding, contains the nucleus, nuclear model. The electrons orbit the nucleus, nuclear model. The atom is mostly empty space, nuclear model. Negative charge throughout the atom, plum pudding. And that's all, so let's check, and that's all right, okay? So, that is it for today in terms of the discovery of the nucleus. More videos will come in. Up to my next video, be happy and healthy. Bye!